Hi, I'm Shane from Decibels Lab. We have here with us EV Powertrain brain setup, especially for two-wheeler. So the basic fundamentals of this brain setup or the outcome of this brain setup is to understand the different functionalities of a motor controller unit and the functionalities of a battery management system. So as you can see here, it contains a traction battery pack, traction motor, motor controller, the wiring harness, the HMI, the throttle body along with the brake setup, the complete wiring harness, a DC-DC converter for the auxiliary system, and a relay, a charger, and a brake lamp along with the rear indicator. So now we shall look at our HMI and the switch case. So on the left hand side, you have on, parking to drive engage, which you can see here. It's in parking now. When I engage, it's in the drive. Then you have switches for indicator, high beam and low beam, parking light, then the speed modes, reverse, and the sports gear. Now we shall look at the different gear systems. That is the different speed modes. You have first, second, third, and the last sports mode, which is fourth. Now we shall look what is the difference which you see in the speeds of the motor. So now it's engaged in first. As you can see, the speed of the motor is low. Now it's engaged in second. Its speed increased. This is the third. Finally, in the fourth way. Let's engage the reverse now. So as you can see, it's moved slowly in the reverse. Now we shall look at the other auxiliary systems, that is the indicators and the headlight. So we have the left indicator, right indicator, parking light, main light engaged, high beam, low beam. Now we shall look at the motor controller functionalities. So we have a driver specified for the motor controller. So it's a CAN based motor controller. So which you can see that we have connected to a system now. Once we connect, we are able to see on the page 1 the model which we have connected, the voltage, over voltage, under voltage, and soft under voltage. All these basic parameters which you can see on the first page. So basically the bus bar current is the maximum current of the motor controller. So on the first page also we can tune the throttle input, such as what should be the maximum voltage and what exactly the throttle input, whether your rate of rise, that is when you accelerate, at what rate it should accelerate the overall motor, and rate of declination when you decelerate, what should be your rate of deceleration. So when we come for the page 2, you have current limiting. So that's the overall current limit which you are giving for the sports mode, and flux weakening value, which is basically depends upon the different motors and the motor controller combined to it. So we have hill descent climb enabled, or hill assist climb. For example, your vehicle is moving downhill, your vehicle is moving uphill. By enabling this, you get certain amount of torque and a certain speed limit to assist you basically where the downhill and the uphill conditions. We can speed limit, so we can set a overall speed limit of the vehicle. Also we can set the 3 speed modes which I showcased here, first, second, third, individual on the first column of the speed and on the second column of the overall torque. So for each speed modes we can set certain speed limit and certain torque limit. So there's also one more functional called as soft start enabled, where basically if this is enabled, you get better smoother start when the vehicle is from standstill. So when we go to the page 3, so this is more about the motor's hardware information, such as what is the number of pole pace, what type of motor, is it V-type or surface mount. So usually mid-mount is V-type and the hub motors are surface mount. And the hall shift angle, And also there's a function called as moving vehicle booster, which will basically, when your vehicle is not in a running condition and the vehicle is still off, when you move the vehicle, the motor will assist, or I would say help you to move the vehicle by giving a certain amount of torque. So we can set the reversing speed limit here along with the EBS ratio. So this motor control also has an ability for the regen braking. So that means when we apply a brake or when we decelerate, there a certain amount of energy dissipated, which will be again going back to your traction battery to recharge the battery pack. This percentage can be controlled here. So this is the display. So you're getting the live data of the voltage, motor speed, current, and all the fault codes, and the controller temperature, external temperature. For example, I'll run the motor now. So you can see the overall RPM which is being increased. So here we have the port setting. This is basically from the manufacturer itself. So these all functionalities you can basically learn with this bench setup by understanding the complete motor controller functionalities and the features which it has. Now we shall look on the battery management system. That's the BMS functionalities. So this is the battery management systems software interface which we have here. It's basically from JPT tools. So on the first page you can see pack information, each series voltages and the balance parameter if it's on or off, the temperatures of the BMS and also of the battery pack. There are n number of temperatures placed in certain region. So here you have pack voltages, current, average voltage, maximum voltage, minimum voltage, what is the different voltage, cycle count, full charge capacity, and overall the SOC. As now it's shown 100%. So here you can see the remaining SOC as it's being shown 100%, which is lesser currently, but now as we have connected right now, it takes some time to adjust and showcase you. Here you have two MOSFETs. One is related to charge, one is related to discharge. MOSFETs are nothing but a gateway or a switch which acts for the particular parameters such as charging related and discharging. Here you have all the warning window such as cell over voltage protection, under voltage protection, and so on. This is the model number of the BMS. So when we come to the second page, that is where we exactly give all the basic parameters. So that is cell over voltage protection, cell under voltage protection, pack over voltage protection, under voltage protection, charge over temperature, under temperature, discharge over temperature, under temperature, and finally we have charge over current protection and discharge over current protection. The first column which you see is the boundary condition. That's the limiting value which we indicate. So these all values are according to the cell or the battery pack data sheet. We do not enter any values which is out of the data sheet of the battery pack or the cell, right? Then you have a release value. So this is your boundary condition. That is where when the activation or deactivation engages. Basically the deactivation engages in the first column. That's the boundary condition. And the release value where the activation engages. So these are the values where the BMS will activate the whole system again from the deactivated state. And the third column is the delay time. So a delay time is given to basically to take some time to read the basic parameters once again. So this cycle continues until unless these values are attained. So we also have second layer protection values here for the overall short circuit, and we have other functionalities such as balance function, charge balance or only while discharging balance, and the NTCs which are connected. So basically we read the program whenever we come to the page 2 to see the latest program which has been engaged. So as you can see, the screen changed and the values changed. So every time when we connect the overall BMS, once we read it, the last configuration of the BMS will be showcased here. And this is the right, whenever we make any changes here, we write it. Also we can save the program and we can open if we have multiple programs. So here is regarding the cell or the battery pack capacity configuration, which will help us regarding a term called as SOH. It's nothing but state of health, for you to give an adequate more realistic values of the battery pack SOC and the range with the in terms of the usage along the prolonged usage with respect to time, right? So it also has some other functionalities such as calibration. These are only done with engineering skill, which a person who knows about the battery pack which has been built, and certain value for each series. So here cell represent basically a series. So we have a 13-inch series currently, and we have other functions. So yes, this was the brief of the conclusion about this EV powertrain with the bed set. So which focuses mainly on the functionalities of BMS and motor control and the overall powertrain bed setup of the vehicle. Thank you.